Example 3 is going to take it one step forward. Here I have a piece of metal with a mass of 14.68 grams, decreases in temperature from 109 to 30 degrees Celsius when placed in 25 grams of water at 25 degrees Celsius. That's a lot of numbers and a lot of words. So I'm going to draw a picture to help myself sort it out first. Here's my glass, it has water, and I have my metal object. I have a piece of metal with a mass 14.68 grams, decreases in temperature from 109 to 30 degrees C. It's placed in 25 grams of water at 25 degrees Celsius. I don't know what it goes to. Okay, this is what's given to me in the problem. I know I have a change in temperature, so I have to use Q equals MC delta T, and I list my variables just like before. Some things I know about this calorimetry problem. I know that my Q of my metal and my Q of my water, the amount of energy, is going to be equal but opposite in sign. So one is going to be positive and one's going to be negative. I know that my final temperature, both my metal and my water, are going to be the same. From the picture I've drawn, I know that my metal has a mass of 14.68 grams. I know that it goes from 109 to 30 degrees Celsius. So it starts, its initial temperature is 109 degrees Celsius. It goes to 30 degrees Celsius, which I can then find change in temperature, final minus initial, so negative 79 degrees Celsius. I know I have 25 grams of water that are starting at 25 degrees Celsius. I know my final of both are the same, so it's going to both end at 30. Final minus initial gives me positive 5 degrees Celsius. I also know my specific heat of water. It's always going to be 4.18 joules per gram degree Celsius. This is all the information I know right now. I still have 3 holes, and inevitably, I want to know the specific heat of my metal and what metal it is. Well, I can't just get there in one step. But I know first I can find my heat of my water. Then I know that that's going to be equal to the heat of my metal. And from there, I can solve for my specific heat. So, step number 1, Q of my water is equal to MC delta T of my water, mass 25 grams, specific heat 4.18 joules per gram degree Celsius, change in temperature 5 degrees Celsius, gives me a Q 522.5 joules. Plug that in for number 1, 522.5. That's equal to the mass of my metal, except the mass of my metal is going to be negative. My metal lost heat. So this is negative 522.5. So step 2, Q of my water equals negative Q of my metal, 522. Now step 3, I have my Q, my mass, my change in temperature. I can solve for specific heat. Q of my metal is equal to the mass of my metal, specific heat of my metal, change in temperature of my metal. Looking for specific heat, so I divide both sides by mass times change in temperature. So specific heat of my metal is equal to the Q over mass times change in temperature. Plug in, I have negative 522.5 joules divided by mass of 14.68 grams times my change in temperature of negative 79 degrees Celsius. Joules per gram degree Celsius. That's specific heat. When I do this, I find my specific heat is equal to 0.451 joules per gram degree Celsius. Now when you go on your reference guide, you'll see a table. On that table has a list of metals, and next to that is a list of their specific heats. You'll find that the one with the specific heat of 4.51 joules per gram degree Celsius is iron. Okay? Alright, go ahead and try your U-try. You're going to follow this exact same step. Go back and watch it as you're working through your U-try. You should find that you have zinc.